Today, you are going to identify intersecting parallel and perpendicular lines. So lines that cross are called intersecting lines. So just like this picture here, they meet at this one point right here. However, if the lines intersect at a right angle or 90 degrees, then we call those lines perpendicular. And if the lines never meet and they go on forever and ever and ever, but they will never intersect, we call them parallel lines. The red and orange line, they each have a slope. It looks like we're going down one, over one, down one, over one, down one, over one, down one, over one. Or we could even say we're going down 4 over 4, but that simplifies to -1. So the slope of the red line is -1. And the orange line also has a slope of -1. Since they have the exact same slope, that means they are parallel. They are never going to intersect when they have the same slope. All right, orange and yellow. The orange line, we just figured that out up here. It has a slope of -1. And the yellow line is up 2 over 2. Which simplifies to 1, or we can even go up 1 over 1. There's really a dot right here too. Up 1 over 1. So that one has a slope of 1. Now, this probably wasn't the best number to use. Let's say we have, actually I'm going to do a fraction. Let's say we have 2/3. If we were to flip that upside down, we would get 3/2. And then if one of these is a negative, so I'm going to make the second one negative, these are called opposite reciprocals. So they have the opposite sign and one is flipped upside down. When we have a case like that, that means it is perpendicular. Okay, so orange, I'm going to actually add a 1 on the bottom. We can flip 1 over 1 upside down to still have 1 over 1, but this one is now positive. So those are called opposite reciprocals, which proves that those two lines are perpendicular and they meet at a 90-degree angle. All right, yellow and green. So the slope of the yellow line is 1. The slope of the green line is 0. So those lines are intersecting. Those slopes have nothing to do with each other. Green and blue. The slope of the green line is 0. The slope of the blue line is up 2 over 2, which simplifies to 1 over 1, which also just simplifies to 1. And those slopes are not in any way related, so they are intersecting. All right, yellow and blue, those both have a slope of 1. Or you could even say they both have a slope of 2 over 2, but it simplifies to 1. Since they are the exact same slope, they are parallel. And then for orange and blue, orange has a slope of -1. Blue has a slope of +1. And those are opposite reciprocals. So those two lines would be perpendicular. So if we were to extend this line right here, they are going to intersect here at a right angle or at 90 degrees. And sometimes you will not have a picture. You'll just have an equation. So if we have this original line, we can see that the slope is 3/5. So if we're comparing line 1, we have the same slope, but a different y-intercept. Because we have the exact same slope, line 1 is going to be parallel to the original line. Line 2, this one is -5/3, so they took this original fraction and it got flipped upside down. And then it's the opposite sign. So that is called the opposite reciprocal, which means this line is going to be perpendicular to the original line. So that means they're going to cross at a 90-degree angle. Line 3, this one just has a different slope, but it is in no way related to 3/5. So that would just be intersecting. So if we have a slope that is not 3/5 or -5/3, if it's anything else, so that would include 1/4, 1/2, 3/7, 2/3, that means it's going to be intersecting. It will meet the other line at some point, but it's not going to be perpendicular. All right, and line 4. This one, they're really trying to trick us because it says 6/10, so we're thinking it's intersecting, but 6/10 is really the same as 3/5. Because if we were to simplify 6/10, we would get 3/5. And it has the exact same y-intercept. So those are the exact same line. So they would overlap each other on a graph.